A welding helmet is a type of headgear used when performing certain types of welding to protect the eyes, face and neck from flash burn, ultraviolet light, sparks, infrared light, and heat. Most commonly used with arc welding processes such as shielded metal arc welding, gas tungsten arc welding, and gas metal arc welding. Welding helmets are necessary to prevent arc eye, a painful condition where the cornea is inflamed. Welding helmets can also prevent retina burns, which can lead to a loss of vision. Both conditions are caused by unprotected exposure to the highly concentrated ultraviolet and infrared rays emitted by the welding arc. Ultraviolet emissions from the welding arc can also damage uncovered skin, causing a sunburn-like condition in a relatively short period of welding. The modern welding helmet used today was first introduced in 1937 by Wilson Products. Most welding helmets include a window covered with a filter called a lens shade, through which the welder can see to work. In most helmets, the window may be made of tinted glass, tinted plastic, or a variable density filter made from a pair of polarized lenses. Speed glass auto-darkening filters. In 1981, a Swedish manufacturer named Hornell introduced the speed glass auto-darkening filter, an LCD electronic shutter that darkens automatically when sensors detect the bright welding arc. With such electronic auto-darkening helmets, the welder no longer has to get ready to weld and then nod the head to lower the helmet over the face. The advantage of an auto-darkening filter versus a traditional passive filter is that the welder does not need to adjust the position of welding helmet manually, which not only saves time but also reduces the risk of exposure to the extremely bright and harmful light generated by the welding process. In January 2004, 3M acquired all assets of Hornell, including the Speed Glass auto-darkening helmet's brand name and patents. Speed Glass helmets are now sold by 3M. Mann Glass. In the 1970s and 1980s, Steve Mann introduced the Generation 1 and Generation 2 digital eyeglass, initially as a vision aid to help people see better. Some of the early versions of this apparatus were built into welding helmets and used for welding. See also IEEE Technology and AMP Society 31 and the supplemental material entitled Glass Eyes. The device is an example of the full virtuality-mediality continuum on both the virtuality axis and the mediality axis, thus being able to implement, for example, diminished reality. In the 1980s and early 1990s, Mann invented high dynamic range imaging, which combines multiple images to allow highlights and shadows to be seen better. Safety. All welding helmets are susceptible to damages such as cracks that can compromise the protection from ultraviolet and infrared rays. In addition to protecting the eyes, the helmet protects the face from hot metal sparks generated by the arc and from UV damage. When overhead welding, a leather skull cap and shoulder cover are used to prevent head and shoulder burns. Welding goggles. Green glass goggles are needed use for torch welding and also have ANSI standards. When viewing metal that is visibly hot for longer periods, protection is needed for the eyes. While it seems to be low light, the wavelengths are bright in non-visible spectrum. These are easier to see through and wear than helmets. ANSI standards. In the United States, the industry standard for welding helmets is ANSI Z87.1+, which specifies performance of a wide variety of eye protection devices. The standard requires that auto-darkening helmets provide full protection against both UV and IR even when they are not in the darkened state. The standard is voluntary, so buyers should confirm that the helmet is ANSI Z87.1 compliant.